Hi everyone. In this video, we will learn more about R, the programming language we will be using for assignment 2. So I will start the notebook by clicking here on Launch Notebook. It's important to remind you that you don't really need any previous programming experience for this course. We will provide pre-existing code in assignment 2, and you will only have to do some minor editing. So if you have any questions or you feel insecure regarding your programming skills, just contact me and I'll be happy to help you with this. In this video, we will talk about what is R and also the different types of data we will be working with, how you define variables, how you work with expressions, how you call functions. And also we will talk about two specific types of data structures, vectors and tabular forms like data frames. So starting with what is R, R is a programming language that allows us to communicate with computers. And just like any language, it has a vocabulary and a syntax, a correct way of saying things so that the computer will understand us. So why do we need R? We were okay working with Excel in assignment 1, but I would say there are two very important reasons why we want to work with R. The first one is that R was specifically designed for statistical analysis. So it has a lot of built-in functions and packages that allow you to work with data easily. And also it's well tested and documented. So whenever you want to do something that's more complex than just calculating an average you can easily calculate it in Excel. But if you want to do something more complex, like building a supervised learning model, R is definitely better and easier to work with. And the second reason is the size of the data set. So Excel allows you to work with a million rows at most. And also it gets kind of hard to work with very big files. Excel starts becoming really slow. R allows you to work with bigger data sets more efficiently. You can work with hundreds of millions of rows and columns, and it's usually no problem for this programming language. So moving on to the data types we will be working with. The first type and the most popular we will be analyzing is numbers. So in this case, we have numeric data in these code cells. You can have floating type, which is decimals. You can have negatives, positive numbers, big positive numbers, and also big negative numbers. Uh, we can run this code cell, and since we're not doing anything with the data, the only thing that's happening is that we're printing the values of this numeric data. Then we also have text data. You can recognize it because it's usually between double or single quotes. It can contains just one character, two words, or a whole paragraph. The most important thing here is that it's always between double or single quotes. And also you can have a number, in this case, stored as text. So if we run this code cell, what will happen is that we're printing this code. You can see that in this case, R is reformatting and only stores it as a single quoted text, but there's no problem, it still works. And finally, moving on, you also have logical types of data, in this case, true or false. And this data will be really useful whenever you have a if-else statements. That means whenever you have a condition you want to keep working on. For instance, let's say if a variable has certain value, you will follow a specific logic flow. That's why we would be using logical types of data. Second, we will learn about expressions. So you can build expressions by combining different different data values as the ones we used before. In this case, we can build an expression by adding 14 and 20. And in this case, if we run this code cell, we will just get the value of this expression, 34. You can also compute many expressions at the same time. Each line in this case will be considered independently. So we have, in this case, 4 expressions, and we will get the value of each of them. So if we hit run, we get the value for each of these expressions on top. We can do many basic arithmetic operations like multiplication, addition, subtraction. We can do them one step at a time. We can do them all at the same time, like here, and everything works without any issue. We have left some space on this notebook so you can practice building your expression. Something that I think it's interesting if you want to work with powers that is built by writing 2 times the multiplication sign. So if we want 3 raised to the second power, that's how you write it. Now, it's also important to understand when you have an error. So in this case, in the following code cell, we have the print function. The syntaxis for using functions considers these brackets. You need an opening and an ending bracket. And in this code cell, we didn't write the ending bracket. So that should generate an error. So if we run it, we will see error in pairs, unexpected end of input. So that means that the R expected something else before ending, and we didn't end it correctly. So it will show the start of the line where you had the problem. It won't show exactly where it's happening, but this comment, unexpected end of input, you can put it on Google. Probably a Stack Overflow page will appear, and you will be able to find some common reasons why that this is happening. The good thing is that you are able to edit this and rerun it again as many times as you want. So just be confident you're able to understand this explanation of the error, and you will be able to find a way to solve it. There's no need to worry about it. Second, you are able to name expressions. You can store the values on variables like this. You can say, in this case, you're storing the value 442 in the X variable. You can put it with an equal sign, or you can do that also this way with an arrow. Both mean the same, so you can use whichever way you prefer. If you run it, you will store the value. If we run it again and maybe we change the value, we will now have a different value on the variable. It doesn't print anything because we're only storing. We're not telling R to print the value. That's what we do on the next code cell. So if I run this, it will print the last value I assigned. And also, it's really important that you make sure you stored a value before, because if you just run X without having assigned a value to it, it will show an error because there's nothing there. So let's change this and test it. I haven't put anything on the Y variable. So if I run it, it throws an error. It says object not found. So that means I probably forgot to run a code cell before that assigned a value to Y. That's a very common error. So moving on, I can also do those 2 operations on the same code cell. I can store some value in Y and then print it. I can then also print some things without having to store them. I can use the previous value I had on X and subtract 42. And I can also play with X and Y, adding them, multiplying them, whatever you want. So here again, we are given some space to play with this. I could take X and raise it to the Y power and see what's that value. Cool, so moving on, we talked previously about functions. There are many built-in functions which we will be using. The good thing is that these functions have usually been optimized, so they are able to do things as quickly as possible. And sometimes it's very complex functions that we're really thankful about having them implemented in R. So in this case, we will check, there's the round function. It's a built-in function. If I run it just by itself, it tells me it's a primitive type. So it's already been developed and it's like in the underlying R system. Whenever you have a function, you can always put a question mark in front and run it, and it will show you the documentation of this function. So you can check how you use it, what's the input it needs, some similar functions you might be interested in using it with, the arguments, the details. It's very useful to do this whenever you're not sure how you use a function or whenever a function throws an error because you forgot to add part of the input. So in this case, we check the function and we realized we needed to put the integer we wanted to, not the integer, but the floating number we wanted to round up. So it rounded it, no problem. There's also, for instance, the min function. If we run it, it takes the min out of all these values. So there are many built-in functions. You can always look on Google, how do you calculate this? And you will probably find a function that's already been developed and you can just call it and use it. So in this case, we propose an exercise to use the absolute value function, abs, or you can use the max function. So I will use the abs function with -4 value. I run it, it gives me the absolute value of -4. Good. So moving on, there's an interesting type of data structure called vectors, where you can store many numbers or different entities. You could store also a vector of strings. So in this case, I'm storing in the numbers variable a vector. This is the syntax. I put a C, then a parenthesis, and then all the elements that make this vector. In this case, the vector has 6 numbers, and I will store them on the numbers variable. So this is my vector. And I could work with this vector by retrieving one of the numbers. That's why I would use the square brackets and put inside the position of the element I want to work with. So in this case, I'm calling the second item in the numbers vector. It's 8. And I can also call some functions on the vector. So for instance, I could use the min function to calculate the mean of all the elements inside this vector, or I could use the sum function and it will do things automatically. So as you can see, it's very easy to work with. You can also do arithmetic with vectors. So I could, for instance, declare another vector and I could add these two vectors. It would do the addition element by element. So in this case, we're adding the first element 2 with the first element of numbers, which is 4. So that's 6. And that's done for each element within the vector. And here you can also practice. We could, for instance, multiply these vectors. And it does it element by element. The last thing I wanted to talk to you about is data frames. Data frames are a way of organizing information in tables. Uh, Once again, R is a programming language that was designed for statistical analysis. So this type of structure, the data frames, are optimized to work with data efficiently in table form. So it's very good to learn how to work with this efficiently. Um, you will have columns that store different vectors, and each row would be an instance within that vector. So I could have, for instance, in a tabular form, the data of an employee, and the different columns will be the attributes like the age, like um his address, his region, his birthplace. Um, and I could work with that with many employees and get some basic statistics around it. So in this case, the columns typically represent a feature of the data, such as color, price, name. And you can also think about data frames in terms of its rows or the instances we are analyzing, like a person participating in a research study, a day of stock trading, or a product at a store. In this case, I will load the data frame from a file, a CSV file, the one we used for assignment 1. It's stored somewhere in the server, so I just need to read this CSV. That's the function we're using, and I'm giving here as an input the location of the file. And that will be stored on this HR variable. So when I run it, I have stored the information of the file on the HR variable as a, as a data frame. So some interesting functions to work with data frames. First, we have the head built-in function, which shows some of the columns. It would take 5 or 6 rows, and you can see the structure of it. So you can easily see it has the age, attrition, business travel. You can see all the columns it has and the shape of this table. So what else? Another interesting functions we have on data frames, we have the dim function, which will show you the number of rows and columns. And also you can get a list of the names of the columns by calling the call names function. So by running this, I see first the dimensions. It has 1470 rows, 35 columns, and these are the names of the columns. And finally, I can also retrieve just one column by using this $sign and calling directly the attribute I want to have. So this is calling the department column of the HR variable. You can see this department column has sales, research, and so on for all the rows this data frame has. There are many resources if you want to learn more about R. As I told you before, we don't expect you to have any previous programming experience, and you can learn a lot of programming. So this all depends on how interested you are on this. I'm available if you have any questions, but otherwise feel free to explore these resources we have to learn more about R, to learn more about Jupyter notebooks, and also from different machine learning, text mining resources available. Also, I suggest you to explore these books. There's a lot of content, so you won't probably be able to analyze this during the course, but I'd be happy to talk more about this with you. Feel free to contact me. See you soon.